All right, good morning. This is May 15th, 2025, ELEC 1013, Network Cabling Course, Fanshawe College, London, Ontario. Right, here is the header. Okay, so today is the second part that you're going to receive uh, in regards to the Pro Audio and the PA systems and things associated with that. So I'm just going to start first presentation that we have. All right, so sometimes you're going to encounter a situation like this. It's a full-blown construction site setting up a stage, um, and that was one of the stages designed for the New Year's Eve. It took about 2 weeks to put that thing up, and once it was done, it looked like that. All right. And if you want, once you download this presentation, you can just click on that link here, and you can actually see that stage in action. Now, not all the Pro Audio stages are going to look like this. This is, kind of an extreme. However, you might have opportunities to set up a lot of smaller venues with maybe 10,000 watts, 20,000 watts, up to 100,000 watts. That's considered sort of like a medium size um, stage setup. Okay. Sometimes it's just, a couple thousand watts or maybe 3 or 4,000 watts for, well, up to 500 people. And yes, you can get hired doing that. Live audio, I would say, live mixing. It's a lot of work, but the money is there too if you make yourself known in that kind of industry. All right. So, what's the live performance typical stage setup? Now, we distinguish a couple of different setups right now. One type is the old school analog, which is still being used, not as much as it used to because it's being pried out by the digital setup. They are mostly the same. They have the same elements. They look the same, except there's a slightly different approach. There are certain differences, pros and cons to both. Okay. All right. So what do we have here? Is this part here? Okay, right here that I'm drawing a circle around it, or the ellipse. This would be the part that is called the front of the house. Front of the house is where the public is. Now, in order to get the good sound reference, the main mixing board that is mixing the sound for the front of the house is pretty much almost at the sweet spot quite often at the front of the house. Now, over here, we have the stage area. Okay. Now, in both systems, digital and analog, you're going to have a mixing board at the front of the house with a connecting link that connects to the mixing board to the, over here, it's called a stage box. Now, in analog systems, the inputs on basis on one-to-one are going to be connected to the input. So they're just extended inputs in the stage box, and the stage box will be passive, which means there's no power needed to power up the stage box. Okay. And the cable that is being used to connect the mixing board to the stage box, it's a thick cable having a lot of wires encased in it, and it's called a snake. The snakes could be 50 feet, 100 feet, 150 feet snakes. And there could be, well, 12 inputs and maybe 2 or 4 returns. I'll tell you what those are. So the snake would have inputs and it would have returns. So the inputs are the channels that have the direction of plugging something in here and sending the signal to the mixing board. So these will be the input channels. The returns would be also same kind of cables inside that snake, but their direction would be from the mixing board to the stage box. There will be these are called returns. Very simple reason why do we need that kind of direction, well, direction oriented signal routing. Well, the impedance, and don't worry, we'll talk about what impedance is as long as what characteristic impedance is. And I'm not sure in a couple of weeks or something like that. So you might want to come back to this. Well, impedance is the resistance and reactance combined. Okay. So it's the resistance or the impedance of the input or output of whatever device. So the inputs of the mixing board are in the range more or less about 600 ohms. Sometimes 150, 300 ohms. So anywhere from 150 to 300 ohms to 600 ohms. Big spread, right? Well, that's what it is in the but 600 ohms is quite common, more than others. So if you look at that resistance of the wire, that is going to maybe, if you have a snake that is 100 feet long, the resistance itself of the conductors that are in specific channel could give you maybe 3 ohms, 5 ohms. So that compared to 600 is kind of negligible. So just keep that in mind. So we're talking about analog setup right now. So this will be the female jacks here. And it will be just permanently connected. The snake, the wire, the big snake wire would be permanently connected to the stage box, containing all the wires connected to all the inputs here, maybe from 1 to 12 or 1 to 16 or 1 to 24. And it's going all the way here, and it is ended with, those are ended with male outputs that are plugging into the female inputs on the mixing board. Now, the returns have the gender switch the other way, because the outputs of the mixing board are going to be the male jacks. So you need to adjust the gender accordingly to the snake, to the wire, to the signal direction in those channels that are called returns. And you send the signal back to the box, and there would be different gender males here, returns. So the signal from the mixing board goes also back here. Why do we need that? Well, over here we have the sort of like a simplified version of the front of the house loudspeakers right here and right here. So here's the bass and mid and highs, bass, mid and highs. Very simplified kind of a diagram, just to show you the idea. Well, the speaker impedance at the front of the house, at the stage, not at the front of the house, at the stage location, that will have sometimes 8 ohms and sometimes 4 ohms if it's a higher powered system. So if you have 4 ohms impedance of the speaker here, and if you have an amplifier that would be right here at the front of the house, and of course you would have a thicker cable going in there, not just a thin cable, maybe 22 gauge wire going for the signal because it's a low power. Now the higher power will be well 12 gauge wire maybe or something like that. Yes, it's going to give you less resistance, but still will give you 2 or 3 ohms compared to 4 ohms. That is unacceptable because the losses would be just too much. So, as I said to you before in the previous class, it is crucial that the speakers are at the closest possible distance from the amplifier, so the resistance of the speaker cable coming out of the amplifier is not going to be that much. Well, so we need to put those amplifiers right somewhere at the backstage or close to the, maybe under the lip of the stage. So, but we need to bring the signal, excuse me, from the mixing board to the amplifier. So thus we have those returns. So here's the inputs. Signal gets processed into some whatever groups, and the final version of the signal or final version of certain channels. And the returns are being sent back to the box, and then they are being plugged in to the amplifier. And the amplifier, so here's about 600 ohms impedance, and here's low impedance, about 4 or 8 ohms. So that's why we need to have the amplifiers on the stage. Right. Now, when it comes to the digital system, yes, we also have a stage box, but the stage box will be active, which means you have to power that box. You have to plug it in. And it basically has all kinds of electronics in there. Quite often, the whole heart of the system is in the stage box. And what's at the front of the house is just a mixing board that would act like a remote control for the main mixing board, which is here. You could have basically a PC that controls that. Or you will have a full-blown digital board here connected with the stage box through an Ethernet cable. So there's no multiple wires going in the snake. So it's going to be just an Ethernet cable, Cat6, Cat5e. And that is going to contain all the information there. So you don't need to have a thick cable. Now, the pros and cons with just that aspect of the Pro Audio would be that, let's say one of the wires gets broken, or maybe some connections iffy, dodgy, or whatnot, and it's going to give you some sort of unwanted noises. So, the most stressful situation is if it happens half an hour before the show, and you have to find out which channel that is giving you problems. So, yes, there were situations like that. You just abandon that broken wire connection, and you're going to fix it later when you take it home or to your shop. But you have all the other wires, channels to be used. If there's something wrong, if something goes wrong with the digital system, which would be the Ethernet cable, Cat5e or Cat6, then the whole communication goes down the toilet, and it sounds like the skies are falling to the point that they can actually damage the speakers by that unhuman noise that no human should be subjected to it. It's a terrible, terrible noise. So that's pros and cons. But that's why you always need to take care of your wiring. And there's a certain way cables should be coiled up or wound, certain way that they should be stored, and certain way that they should be treated while using them for work. So the stage box would have a bunch of inputs here. Either the stage book is digital or analog. Um, and then we're going to have some returns. Also, we're going to have some groups sent to something that's called stage monitors. The purpose of the stage monitors, it could be a wedge type of a speaker because it's kind of like looks like a wedge. So here's the base of the speaker. I mean, like base, you know, the thing that the speaker stands on. All right, here's the enclosure, and the speaker would be like that, shooting the sound that way right there, upwards, at the person that is, who is performing. And these are called hearback or stage monitors. And the purpose of that is so whoever is performing, they have some sort of reference of what actually is going on, what that person is playing, what there are other people who are playing. So there could be different stage monitor mixes or groups of channels being sent to specific monitor. Like, for example, the vocalist, they might want to hear some of the guitar. They don't want to maybe hear a lot of drums, but they might want to hear some keyboard, guitar, and then maybe some bass and a specific balance. Now, the guitar player wants to hear his guitar, maybe, or her guitar, slightly louder, so for their own reference, and maybe they want to hear some drums and bass, not too many keyboards, whatever, not too much keyboards. So those stage monitor mixes could be adjusted for each and individual performer who's performing at the stage. I didn't draw this here, but they're also something that's called, and they are at the side of the stage, shooting the sound this way, and on the other side, shooting the sound that way. And those are called stage fill monitors, and they give the sort of a general overall sound of what's happening at the front of the house, because if those speakers are pointing forward to the general public area, and if the performers are standing behind them, there's no way they can hear things properly. So the stage fill monitors, they will give some sort of reference. Can't have them too loud because then you're going to have a feedback. Plus, the microphones are going to start picking up that. So the sound, so everything has to be really, really well balanced. So that's more or less as far as the analog versus digital stage setup. I call that the good old rock and roll type of a setup, but yeah, it works for country as well. Trust me. All right. So also the difference between the digital and analog mixing boards is, well, when the digital mixing boards or the digital systems came on board, they are for for a few years now, few nice years. Well, they made all the analog systems cheaper, less expensive. Well, with the analog, but also with the analog mixing board, and there's some good analog, like you can really have a good sound going on with the analog system. But with that, you have to have all the effects externally connected. So there's going to be another rack with a bunch of effects here, and they have to be interfaced to the board. So there's more wiring here, and you have to buy them. They're physical, equipment. So this was going to cost less, and this is going to cost less. But altogether, when you combine them, well, the price adds up. Okay. Well, with the digital mixing board, most of the external effects go out the window because they are being built in to the board. So you can use them from the board. You just have to call them up. And the digital mixing boards, like for example, if it's like a 48 channel mixing board, it's not going to look as big. It doesn't have to be as big as the as the analog board, because you're going to have like for example, it's going to be a digital display window here, or maybe there could be some graphic interfaces so you can have actually monitors. And you can just call up on the monitor that you're going to use sliders from not from 1 to 8, but from 9 to 16, for example. And those are going to appear on the monitor. And automatically, the levels, there's some stepper motors inside there, they're going to physically move if you select different sections. So you don't have to have all of them at once physically existing there. And, some people like it one way, some people like it the other way. But what's also a huge benefit of the digital systems, and that's why people pay the big bucks, is well, if there's a mixing board that costs $40,000 or $50,000, and maybe some of them less that cost $2,000, there's a possibility of storing all the settings, all the user settings. So if there's a tour with the band, bigger band, quite often the technical crew, they don't bring their own mixing board. They just request that to be set up by whatever local company there is. Sometimes that happens. And they have to request a specific model and specific software version, so it all has to, that can be worked out. And the sound engineers, they just travel there with their jump drive or two for backup. They just plug it into the board, recall all the settings, and boom, you don't have to do as much of a sound check at the stage location as you used to have. You have to do it from scratch all the time when you had the analog board. You would just load up all the settings and then you would just verify, because every location is different, every room is different, just to kind of iron out some details, but you wouldn't have to do the sound check from scratch, hours and hours of the sound check. It would be minutes, up to an hour. So that is the general overview of the, one thing that I didn't mention here, which we're going to talk about later today in greater details. Here's that, it looks like DL, that's a D dot I dot. Direct input box, direct box, or quite often they're called DI box. DI box converts, it's almost like primitive version of a media converter. You could classify it as that with some grain of salt. The idea is to convert the unbalanced signal coming from passive devices, maybe a guitar, or maybe active devices as well, to convert that into a balanced signal. And as we go along today, at the end of this lecture, of this class, I'm just have to watch my time, I'm going to give you the rundown on what the difference is between balanced and unbalanced signal, what the idea is, basically. Oops. All right, here is just a general overview of a simple mixing board. This one has two balanced inputs that are called, these are called XLR. And also balanced input, which is quarter-inch jacks, because here's a quarter-inch. And XLR, I keep forgetting what the acronym is, and I bet that most of the sound technicians, they keep forgetting what XLR is. It's external something, whatever. We'll get it. Okay, if somebody can look at Google that quickly, then I would appreciate that. So the idea is to have the signal balanced. Now this one here can be balanced or unbalanced, but it's a quarter-inch. It's a semi-professional mixing board, so it's ready for whatever comes at it. Okay? And each channel will have something that is called a gain control. So basically, because different instruments produce the signals with different strengths, and sometimes the spread is just too much. So you are making that signal usable for the rest of the. Sorry, I just have to silence that. That's the beauty of online teaching, working from home. Uh, so here's a channel strip. This gain control will make that signal usable. There's a line or mic. So this line level from a keyboard is a strong signal, and microphone level is a weak signal. Line would be like 1 millivolt peak to peak, or 1 volt peak to peak. Somebody is really stubborn to call here, and I'm just gonna have to pick up and hang up. Maybe someone's gonna get offended. I'm sorry about that. So that pod can actually reduce the signal a lot. So stronger signal can be plugged in. And that gain here, there you go, XLR, external line return. Right? I would, never think of that. I would call it something else, something to do with the balanced or unbalanced signal. But XLR, it has a kind of a ring to it. The acronym. Okay, so we just keep calling it XLRs. XLR or quarter inch. That's what XLR looks like. Has 3 pins and quarter inch. It also has 3 connections inside there, or it could have 2 connections. 3 is for balanced. 2 is for unbalanced, and they're arranged in such a way that if you plug in unbalanced type of cable, it will also adjust because of those pins that are touching and making contact. They're going to arrange themselves accordingly. Then you might have a little bit of equalization going on, and maybe some auxiliary effects that if you have one common auxiliary effect, like for example echo or reverb or something like that, this one has a built-in effect. It has some echo, reverb, flanger effects, maybe some simulation of smaller room, bigger room, biggest room, things like that. So you could, if you adjust that to choose one effect, you can, do I have one here? I think I used to have that. 1, 2, 2. Yeah, there you go. See, I got on my mixing board. So the effects can be built in, can be given or plugged in to the auxiliary inputs. Basically, you have to work this out, but that's basically how that works. And here is the main volume of just that one channel. And if you adjust different channels, this one has only 2 XLR channels, and then maybe some couple of line inputs here. But let's say this one is a 2-input channel. Really, I would treat it as that, even though for the sales purposes, technically it's considered more channels, but I see 2 channels here that I care about. And then when you have more channels, you can adjust the volumes, and then you can send one main volume from the output of the mixing board. Or if you have different groups, because you can include those channels in different groups, and you're going to have a main volume for that one group. So you could put all the drums microphones, because microphones for the drums, you probably use about at least 6. One for the kick, one for the snare, 2 and 3 for the toms, and 5 and 6 for the overheads. So there you go. You got 6. And sometimes if you want to just bring the whole drum, so you could put all those 6 microphones on one group, and you will have a main volume control for just that one group. So you just want to raise just the drums, you can do that with one volume control, one slider. Okay. And others, you can have backup vocals grouped as well, like that as well, and so on. It takes a bit of a while to get used to that kind of stuff, and it's you don't learn that thing overnight. But it is once you get the hang of it, it's pretty straightforward. Digital works the same way, except as I said, you call up certain channels on the display and use them as such. This is what the rear looks like. So here's the input. No, that's the top. Now, I'm just going to have those. You can download that thing, the presentation here, and you can just look at that. And if you have any questions, ask me, okay? Because this here, that's just that part of it. And it will take me longer time to go details, but you pretty much understand what's going on here. Quite often people ask me, what's the tape thing? Well, in the past, a tape deck would be interfaced with those. Those are called RCA jacks. And see, it says unbalanced. Okay? And those would be connected to the tape recorder. Well, now you can connect them to MP3 kind of a recorder or whatever else, digital recorder or whatnot. But the terminology just like stayed. Rarely those are being used anymore. Okay. Now, a bigger mixing board is same as the smaller mixing board, except it just has more channels. And those channels can be grouped because you can assign those channels to the groups, and you have more of the main volume controls. And a little bit of a final EQ stage, which this one also has. See that here. So a bigger board is same as the smaller board, except it's bigger. It has more channels, and maybe some more groups, and maybe some more auxiliary inputs. And here's a couple of the main outputs. You see the gender is different. Here's a female gender for the inputs. Here's a male gender for the outputs there. Okay. This one has left and right. Plus, it has more outputs. And there's a headphone app as well, so for your reference. Now, here is a digital board. You can click to watch the video once you download this presentation. This one is quite common. And if you want to changes from one year to another, this is quite common. Industry standard Yamaha CL5. That's for the big guys. That's for the big bands. And so if somebody could Google the price for Yamaha CL5, CL stands for Control Logic Digital Mixing Board. So depending on the options, you would pay different money, but the bill is not small for this. Yeah. It has some sections of sliders, and here's the display on which group you're calling from, maybe whatever channels 1, 2, 3, 4, 5, 6, 7, 8, 1 to 8, or maybe you want from 9 to 16 or so on. You can and once you call up the display, those are going to move to whatever the settings they used to be physically. And with this one here, yes, you can plug in a jump drive with all the settings, and bang, you have that thing set up, so you don't have to do the sound check for hours and hours. Now, smaller version is here. Just look at that. There is no snake going on. Those are fun events always. Countryside events or festivals and things like that. That's when you make money doing that kind of stuff, servicing that kind of stuff. Look, there's some wedges, stage monitors. There's some front of the house monitors. So I would say over here is about maybe anywhere from 1,500 to 2,000 watts per side. So it's about 4,000 watts, maybe the whole thing, which sounds about right. 4 to 10,000 watts for a venue like this. And then look, there's no wires. The stage box is the brain. It actually is this here, except it doesn't have sliders. It's just a box. It just has the electronics. So it's somewhere there, the stage box, with all the instruments plugged in. And over here, we only have the wireless controls. So here's our mixing board. and they're connected wirelessly. Pros and cons also is that if you use analog system, you have to have this thing plugged into the same power source, same electrical panel. So if there's well, here's no problem because you would just have to take the extension cord anyways and plug the analog mixing board here. But quite often, what happens is that there's a big, well, concert hall or something like that, and somebody plugs in all the amplifiers and the control equipment somewhere at the backstage, and they find an outlet somewhere on the other side of the room and plug it in. And this would be fed from another electrical panel, and that would be fed from another electrical panel. And there's a wire going, the sound wire, the snake going on. It will create something that's called a ground loop, which sounds like a buzz, 60 hertz buzz. So that's why all those for the analog mixing boards or systems, there's something that's called a distro device, which is basically plugging in to a stove outlet or maybe 100 amps service at the backstage. Has to be done by electrician. And then from there, you have a board with a bunch of electrical outlets. So then from one of those, you run a cable to the mixing board. I'm talking about the analog. Now with the digital, who cares? Because this here is just sending the information of how to control that. So that can be plugged in anywhere. There's no ground loops possibility whatsoever because this is just wireless control of whatever is on the stage. Quite convenient, I might say. A couple of microphones I'm going to show you. Here is, and I'm going to make a bold statement. Some people might agree with me, and some people might go into details. And there are two kinds of people in this world. One kind thinks that the Shure SM58 is the best microphone, stage microphone in the world, period. There was no better, there will be no better for the stage performance. And there's the other kinds that think that we are wrong. There could be some other better microphones. So, you make up your own mind when it comes to that. However, there's something to it, right? So it's a Shure SM58. Click on that link and you're going to have a little bit of a comparison between those microphones, Shure SM57, Shure SM58, and Shure SM7B, which is quite popular for podcasts. It's pricey too. This one here will set you back about $100, and it's good for human voice, for vocals mostly. SM57 is the same kind of capsule, sort of the same capsule, but it has a little bit different head here. It's like more straight, rectangular, and it has better higher frequency response, so it's like tweaked that way, and it's better for miking up like a guitar or things like that, instruments. And then SM7B, well, it is not a studio mic, however, quite often is being used as a studio mic with pretty good results, I would say. SM7B is mostly called like for the broadcasting purposes. I'm not using that. I'm using some other microphone, which I was able to adjust to the way I want this thing to sound. But SM7B is the proper mic for podcasting and radio shows and stuff like that. Could there be any better mics that would give you better sound response and things like that? Yes, could be. All right. But then again, if you listen to a pure sine wave, an example, you listen to a pure sine wave, it's going to make your ears hurt. But if you look at the sine wave on the oscilloscope, yes, it looks nice, pretty definable, tangible. You can see it. You can wrap it around your head, or you can wrap your head around that. Sorry, wrap around your head. Or if you listen to a bunch of violins playing, it is going to sound wonderful, but it's going to look ugly on the display, on the oscilloscope. You won't be able to see one end from the other. So the same thing. Yes, there could be better microphones or something like that, But these here, they carry the sound a certain way that is pleasing to the human ear. For example, the SM7B microphone, uh, you can listen to that microphone for hours upon hours and not get tired. Your ears are not going to get tired as if they would from another more crisp microphone. Yeah, so here's the idea. So click on that, and the best thing would be if you have good headphones to listen to hear. Okay, so some of them, and I'm going to ask you on a test. Some of them, like for example, SM57 is mostly used for miking instruments on the stage. This is stage, not studio. Right? And then SM58 would be stage vocals, the best for the stage vocals. Although some people choose to mic instruments with SM58 and some vocalists choose SM57. Personal choice sometimes. And here's SM7B that if you want to record low budget studio thing and still sound good, yeah, that would be podcasting or would be used in the studio. Balanced and unbalanced signal. Let me just get another presentation going on here. We're doing good. There you go. What's going on with the balanced and unbalanced thing? Here is a quarter-inch plug. You see, this one here has only two connections. Here's one connection separated by insulator or a dielectric. And here's the other connection. That one is connected to this prong at the back. And this one tip is connected to this one here, so you can solder a wire. Now here, this one has three, right? Here's the tip, ring, and sleeve. So it has 1, 2, 3 connections. All right. What's going on with that? And here is the, oh, there you go, external line return. I had to write it down because I keep forgetting. You will too. So here's the female version of that, pin 1, 2, and 3. And here is according the male version. So they plug into each other. And pin 1 is a signal ground. It can be lifted. Sometimes it's lifted on purpose to get rid of some noise. Or it could, so the one here, 2, is hot, and here is cold. Okay, what do we mean by all that stuff? Here is how unbalanced link carries the signal. Here's the signal source, could be a microphone, could be guitar, could be whatever. And here's the ground, and here's the ground. So it could be 2 wires. I just didn't draw the other wire. So the ground serves as a ground reference, and the signal wire serves as a signal wire. And that's where the signal is going. Let's say that's a pure sine wave. If there is some sort of a noise, somebody turns the light on, so some machinery on, or a certain type of car drives by, it's going to create a noise, and that noise is going to go into the input of the amplifier. It's going to amplify with the signal, so the signal is going to come through with the noise on the other end. Now, here is the balanced signal. The balanced signal will have, like, if you look at the microphone here, where is it? Oh, we don't have that picture of it. Okay, it's that microphone, SM58. Here you go. At that end, it will have this female. It's an output. Okay. And it will have, there will be one pin, pin 2, and here will be pin 3. And they will send the signal 180 degrees out of phase. So those two wires, here's a ground reference. So this one requires 3 wires. A ground reference, the hot, and the cold. The hot gives you the signal. The cold gives you the mirror image of the signal. So here is where the magic happens. We get something that's called a differential amplifier. Differential amplifier senses the difference between those two inputs, and it amplifies it, passes it as a signal. So if you have a signal 180 degrees out of phase, a mirror image, it is going to recognize it as a signal, pass it through, and it's going to give you one output as a signal. Now, if there is a noise that is introduced to this whole cable, of course, it's going to be in phase because it's going to affect both wires just the same way. So that is going to be in phase. So if this one rises certain voltage, this one also will rise certain voltage. So with the noise, there will be no difference between those. They both will go up. It's not going to be recognized as a signal. It will not be passed through. So you're going to have nice and pure signal. Even if the signal is noisy on the input, you're going to have a nice and pure signal on the output. Okay. So here, this would be plugs. These will be plugs associated with the unbalanced signal. And this will be plugs or jacks associated with the balanced signal. All right, here is a analog audio snake. It has a bunch of wires here, and these are the inputs, and there's some returns. These are the inputs, and these will be the returns. So this one has 1, 2, 3, 4, 1, 2, 3, 16 inputs, and 1, 2, 3, 4, 5, 6, 7, 8 returns. And those are just basically gives the option. You can use either the XLR or the coded range, depending on what you have. So you don't have to look for it, you know. And there's another version of the balance or unbalanced signal explained. Now, I have constructed that balanced or unbalanced signal on multisim, and I have included those files. Let me show you how that works. And this is probably the last slide, these last couple of slides. Here's Bach playing in a rock and roll kind of a thing here. Now, let me bring this up here. Here's the multisim. This is how we can use it. Oops. Is this one no noise? With noise, no noise. Okay. So here's the differential amplifier, and here's the model of the chip. It's an op amp. Here is, I just simulated signal and same signal with the same strength, basically inverted 180 degrees. Here's a scope. So these two signals are getting, this is the same signal, and then its mirror image getting into the input of the amplifier. And over here, let's see what's going to happen. So if I call up the oscilloscope, turn that thing on, and let's start simulation. There you go. We have signal on one pin. We have signal on the other pin. See, they are inverted. Mirror image of each other. Here is the output. Now, let's introduce noise. But the noise, I'm going to introduce 2 more of those generators. But they are going to be in phase as opposed to out of phase from each other. So here's the second with no noise, with noise. See, these two here are the signal, out of phase. These two are the noise, and it's in phase. Let's see what happens. Start simulation. Look, we have a noisy signal, but the noise in both cases is in phase with that. If this one goes up, that one goes up. And this one goes down, that one goes up. So that noise that is in phase, that gets into the inputs of that, is ignored, and you still have a proper sine wave or proper signal on the output. So the balanced systems, the balanced setup is able to carry a weak signal over a long distance. And we're talking about 150 feet. And it will carry a 1 millivolt peak to peak microphone signal, which if you try to use a unbalanced, just a positive and ground, um, then you would hear that microphone very noisy because there's noise in the air. So here is a little bit of, I would say, a little bit more than tasting platter, a bit of a rundown on pro audio systems. There's way more. I didn't even give you the tip of the iceberg, but just to kind of strike your interest. And if this is something that you want to go into, again, talk to me. I will tell you more and I'll set you up with whatever you need. Well, I won't give you money and I won't give you things, but I will tell you what you need to do to get where you want to be. All right. And that's it for today. And I'm going to see you during the labs. I just got an email from the office that we're going to have some switcheroo with some of the lab sections. One of the sections from the Friday lab is going to be moved to Monday morning. Okay. But once I know all the details, I will let you know. You probably got some emails there as well by now. Okay, ladies and gentlemen, that's it for today, and I'll see you when I see you. Thank you very much for your attention.